Okay, so how was your homeworks? Difficult or not difficult? Difficult, right? Okay, let's start from a some homework solution, so you will know how to deal with this type of question. Okay, so I gave you similar homework. Okay, first homework is this in an estimate simple regression model based on 24 observations. So n equal 24. The estimate slope parameter. Okay, so imagine because this is simple. Simple means you have only one x. So the equation is y equal beta 1 plus beta 2x plus L. So they would like to know about this one because they said slope parameter. It means that estimate estimated parameter is 0.31 with standard error is 0.082. And the first question test the hypothesis that slope is zero against the alternative that is not. Okay, so slope is zero means beta 2 equal zero versus is not zero. So this is two tail, right? So second step, t stat equal beta hat minus what you concern over standard error, which means you can use this number over this number. Using your calculator and you will get the number. Okay, thank you. So 3.78. Third step, you have to open the T table. So T table, two tail, right? So you have to open T into 5 and n minus 2, right? Degree of freedom. So 24 minus 2 equal. How many did you open? So when you have to open T table, okay, so let's find T table. You may see, okay, two tail, 0.05, 22, you will get 2.074, yes. So 2.074. So the last step, if you confused, so let's draw a normal distribution. Okay, it's two tails, so you have both rejection region, both on the left and both on the right. And then here will be H naught, this will be H1. Then your second step here. Then it's go to H1, right? So you have to write down that you reject H naught, which means beta 2 not equal 0 at, oh, sorry. I did it wrong, right? It's 1%, not, yeah, sorry. Okay, let's do it again, but the answer will be the same. So instead of 0.09 is 0.01 to tell, so you get 2.819 instead. Okay, sorry. So 2.819 0.819, okay, 0.819 to 0.819. But the answer is the same because it's go to H1, so you have to answer reject H naught, which means you can use H1 to answer. Beta 2 is not zero and okay 1% level of significance. Okay, so this is when you have to deal with this type of question to test the hypothesis, you have to do four steps like this. So second question, similar, but instead of test zero against not zero, they would like to test again the alternative that it is positive. It's positive means they would like to test whether beta is greater than zero or not. So first step, instead of beta not equal, so become beta greater than zero. So H now you can apply either beta not equal zero because the question says so, or the typical way when you write down the H now, you have to pair them with H1, right? So you have to write down beta, no, oh, sorry, beta equal or less than zero. Okay, you can write either way, that's okay, because if you write slope is zero, it means is according to the question. But for your understanding, as I taught you, you have to pair with greater, right? So you have lesser or equal here. Okay, but the answer is the same. So the second step, you have to compute t stat. So t equal beta hat minus what you concern here over standard error. So literally, it's the same number as previous example, right? So you get 3.78 again. However, the third step, because it's one tail. So one tail you have to open T1 tail instead. So T1 tail at 1%, 99 n minus 2. So 24 minus 2, 22. So you go to one tail 0.01 and 22. So you get 2.508. Okay, so 2.508. And then last step, draw the normal distribution. And then greater is on the right. Okay, so it depends on H1. For the fourth step, depends on H1. Okay, greater on the right, but if lesser than, you have to put the rejection region on the left. Okay, so this one on the right, so 2.508, and your answer is 3.78, so it is 1 again, so you have to write down. Okay, you reject H now, which means beta is greater than 0 at 1% level of significance. Okay, so this is the way you answer. Okay, so the C1C, they would like to test again, but this time alternative is negative. Okay, so first step, you can write down beta less than 0, beta 0 or beta greater or equal 0. Either way is okay. Okay? I prefer this way. I think the pair is better to understand. Second step. So again, this formula, right? Same. So you can put this number. Third step is one tail, but one tail at 5%. So you have to open the 5%, 22. So go to the table, G 5%, one tail, 22. Okay, one tail, 5%, 22. So 1.717, 1.717. And last step, draw the normal distribution. But since H1 is less than, you have to put the rejection region on the left or right, left, okay, less than on the left with minus, so minus 1.717, H now H1, but this time, since your calculation is the positive 3.78, so what will you answer this one? Reject or not reject? Not reject. Can I write down accept H now? Can I write accept? No. Okay. You can write that you not reject H now. This is a correct answer. Do not say accept H now. Okay. And then you put H1. Okay. Beta is negative is not true. You still okay? Difficult? Okay. Just keep practicing. Okay. So next question, they would like to test, okay, instead of test being 0, they test being 0.5 instead. So their calculation is 0.31, but they deeply believe that the slope must be 0.5. So can they conclude that slope is 0.5 or not? So you have to set the hypothesis. Okay, so equal must be h now. So beta is 0.5 versus no, it's not 0.5. So to tell. Then second step, T equal beta at the formula will change because 0.5 must put it here. So 0.31 minus 0.5 and yeah, and then you calculate it, you will get minus 2.32. Okay, thank you. 2.32. Okay, third step, two tail. So you have to open two tail 22. Okay, so 5%, right? 5%, 5%. So two tail 5% 22. So okay, this one 0.074. And then last step, draw the normal distribution. And then two tail is now H1, H1. But the second step is exceed the rejection region, so it's go to H1. Then you have to conclude that you reject H naught, which means no, they try to conclude that slope is 0.5 is not true because beta will not equal 0.5 at 5%, at 5% level of significance. Final question, they would like you to make a interval estimate at 99%. So the equation is beta will equal beta hat plus and minus critical value t standard error. So will equal 0.31 plus and minus. Okay, open t 2 points. And then 99% to tail, right? So must be the same as first question. So 2.819, right? Do you okay? Okay, 2.819, right? And then you will get two number. Okay, you have to get two number because you have to minus one time and make a plus one time. So 2.819. So 0.6, 7, okay. 2. Okay, to 0. Wait, sorry. Oops. So that's 2.54, right? Something like that. Okay, so what does it mean? It means, okay, our estimate slope parameter is 0.31, but okay, this is what we estimate. But if I ask you, are you sure about this number? I'm not sure, but I have 99% confident that Leo beta is between 0.07 to 54. Okay, this is the meaning of interval estimate. They may ask you, oh, you can you believe it that the beta is 0.31? Oh, I'm not sure, but I have 99% confident that the real beta must between this value. Okay, next. So next question, they give you the equation and they ask you to compute A and B. So A, since T stat here equal beta minus 0 over standard error or beta over standard error, which means this is 1, this is 2, so 3 equal 1 over 2. Then to compute equation intercept, again, it means you need to find 1, right? So 1 must equal to multiply by 3. So 2.174 multiply 1.257. So equal, right? 74. Okay, thank you. Good. Mhm. Okay, sketch the estimate regression function is mean is will have the intercept here with the positive slope, and the slope is 0.18. So this is MIM, this is EMSH. B, what is the standard error of the estimated slope? Show your calculation. Okay, so they need to find 2. So 2 must equal 1/3. So 1/8 over 5.754. And you will get, thank you. Okay. I think I will make it in the exam. Okay. In my exam, I may hide some number from like this, similar to this, hide some number, and you have to calculate it for me, okay, to make sure that you clearly understand. Okay, next question. State the economic interpretation of estimated slope is the sign of coefficient what you expect from economic theory. So let's start. Okay, this is the positive, which means if which means if PM, oh, sorry, if PMSS increase by 1, which means the percent of male graduated, right? High school graduated, and you may write down male 18 or older who are high school graduate. Okay, the percent is increased by 1, so they increase 1%, right? 1%. Which means MIM will increase 0.18. So this means MIM. Okay, mean income, okay, will increase, okay, in thousands of dollars, which means $180. Okay, or you can write down 0.18 in terms of $1,000, the same. So they have a positive relationship between education and income. Okay, the higher percentage of people that attend high school, the higher income in those cities. It does make sense, of course. Okay, this is the side of the coefficient what you would expect from theory of yes, it is. So it depends on human capital theory. So your goal of the city is that you try to push all the population, especially this is from only from the male. If you push people to be in the education, the higher income they get, which means your city is better. Construct a 99% confident interval estimate of slope of this relationship. So B equal beta hat plus and minus critical value standard error. So equal 0.18 plus and minus critical value. So you have to open T. Okay, so 51 observation. Have to open T 0.975 to tell and 49. Okay. 49, 51 minus 2. And then you have to open the table. Do they have 49? I don't think so. 49, no, we don't have 49 here. Okay, we may use 50 instead, just for convenience, just for convenience. So, to tell, okay, 99%, oh, sorry, 99%, sorry. So, 0.995, okay, sorry. So, 99%, 49. So, I use the closest one just for convenience. No, not this one. So, 995. 2.678. Okay, so 2.678, right? And the B that you added 0.031. Okay, make a calculation and you will get two number and you can answer. So you get two number. So first is to 0.263 and 0.096, right? Okay, so you can answer that. This is the 99% confident interval estimate of slope must between 0.096 to 0.263. Okay, so this is how the homeworks work. And final question. Test the hypothesis that slope is 0.2. Okay, let's do it. So H now beta is 2 versus no, beta is not 0.2, sorry, 0.2. Second step, T stat. So T stat is beta hat minus what you concern over standard error, right? So you calculate and you will get minus 0.645, right? And third step, you have to open. Okay. Huh? New question. Oh, E. Do we have this question? Okay. Oh, you mean this one? Like 99%? This one, huh? D. Okay, so this is C, this is D, and this is E. Too much homework, isn't it? Get too much homework, right? So here's the hypothesis. So this is beta equals 0.2 versus no, it's not. And then we use the t-test, and then we open the t-table. Okay, so open the t-table, set the mean, and in this problem, they didn't tell you about the confidence level. So let's use 99% because previous we already have 99% confidence. So you use the previous number, okay, 2.678. Why not? Okay, and then final step, draw normal distribution to tell H0, H not, H not, H1, H1, but your calculation somewhere here. Okay, which means you not reject H now. So you can answer that, okay, slope must equal 0.2. Okay, find it. Okay, since you have done a lot of hypothesis testing, so I promise you I will test you in the midterm exam. Okay, the first step. Okay, so your practice is worth it. You can use it in the exam. Okay, the knowledge. And then the final question. Okay, so did you try to use EView already? Did you try estimate this? Okay, so you can use software to estimate similar to this. Okay, the figure and the equation. Okay, so I skip A. You can do it, but B, please interpret the result. Do experience affect rate significantly? So this is when you work with real data, okay, instead of do four step now H1, you can jump to see probability. Okay, so typically they can divide into four categories. Okay, you can divide into four categories. If the block is less or equal 0.1, 0.05, 0.01, and is greater than 0.1. If it's less than 0.1, you can say that it's significant at 10%, okay, at 5%, at 1%, and insignificant. Insignificant, no, insignificant. Oh, significant. Ah, yes, I know it's difficult subject. Yes. Okay. So this is what I expect you a lot to know how to read. You will build out because you have to work with it. Especially, I think after you study with me, they have another subject is called advanced econometrics. Okay. So I have teach you so far. You will use it again, of course, but in more advanced level. So this is like the basic. So I teach you the lesson behind why you can read this probability. Okay, and when you work with real data, you can just read this probability. So interpret the result to experience effect with rate significantly. So you can answer that since log is mean probability sin log t, this is of t. Okay, sin of t equal 0.0048, which, okay, which this case, right, less than 0.01. Okay, so is less than 0.01. Okay, so it means experience effect with rate significantly at 1% significance level. Significant level. Or you can write down that is significantly at 99% confident they are the same. Okay, so let's read this together. So after you know it affects significantly, so you can read its coefficients. So it means the estimate equation is wedge at equal this one. So 18.25 plus 0.08 experience, which means which means experience increase 1 year. Okay, the weight will increase 0.08 per hour, right? Hourly. Okay, that's all the homework. Okay, it's very difficult for you at glance, but if you practice over and over, you will get used to it. Uh-huh. But the ultimate goal, I would like you to know how to read print out since it will use a lot when you have to work on research, especially if you design to work using the data. Okay. I think it will be the easiest way if you would like to graduate to use the data in your research. So some people they fear of model. Oh, it's difficult, it's complicated. Can we do other ways like an in-depth interview, like something like that? So it's difficult to find something new and some professor will not agree with you that this is good enough for graduate, something like that. But if you have the model and the model says, so, oh, it's significant, after collecting all the data, it shows that it's significant. Yes, you can graduate, something like that. No question. Okay, so let's get back to our lesson. So this is the final lesson of simple linear regression, which means all the basics that you need to know is included in this chapter. Okay, so from previous chapter, after you get both beta and standard error, this is the typical way when they write down the equation. So beta on the top, standard error on the second row with bracket. And then they always use star to represent the significant level. Okay, so they always use one star that is significant at 10% level, two star for 5%, and three star for 1%. Okay, so since last time we have three star here, so it means this beta significant at 1% level. And next step, when you get the equation, you can use the equation for making prediction. Okay, so to make a prediction, you can do it two ways. So first is the point estimation. It means it's like a first over. If x equals something, what will y equal? And then you have another way to making a forecast by doing interval prediction. So the equation is point estimation plus and minus critical value and its standard error. So it's similar to confidence interval, right? like confidence interval. Then the variance of the forecast error is smaller when first the overall uncertainty in the model is smaller, measured by the variance of random error. So this is the equation of variance of forecast. If I say this is A, B, C, and D. Okay, so this is A part. Two, the sample size n is larger. Of course, this is B part. Three, the variation in the explanatory variable is larger. So xi minus x bar is larger. So this is D. Okay. The value of x minus x bar square is more. This is it. So all of this, they just explain this equation. So let's see what will happen when you do the interval prediction in the next slide. Okay, so this is the average, right? Average x bar. So the interval prediction will have smaller variance when x bar is close to average. It means if you use extreme value, the value that completely different from your example, the variance will become higher and higher. And yes, the accuracy will not so good. Okay, so this is the variance of estimation. The closer to the average, the more accuracy of the model. Example, okay, example. Please find f when x equal 10 at 90% confidence interval. Then you first find point estimation. So 10 here and calculate. You get 19.63. And then you compute the variance of forecast using this formula. And you will, professor, why you have a lot of mathematics? Do not serious, okay? Okay, I will tell you that I will not use in exam. Okay? No, no heavy calculation. No heavy calculation. Okay, and then you can get into estimate that okay, we have 90% confidence that when x equal 10, y will be between this value and those value. Okay, this is the forecast. Okay, you can do point one and you can do interval one. The next one will be the most important in this chapter. We call goodness of it. Goodness of it. Okay, let's recall the memory. So error, okay, error means this is the real value, and the one at the blue line is the forecast value. So the difference between the real value and the forecast value, we call it error. So they say that it is unexplained component. And since we estimate this line, so you get y hat minus y bar, we call it explained component. So together, I call it total variation. So y minus y bar, which means, let's go to the next slide, which means make it square total equal something that you can explain plus something that you can't explain. Okay, total sum of square equals sum of square ligation plus some square error, or total equal explainable plus unexplainable. Okay, so total sum square SST, so sum square total, sum square regression, sum square error. So SST equal SSR plus SSE. Then this is widely used by modeler, so it's called R square. So R square, they have two equations. First, you use something that you can explain over total. So SSR over SST, or you use 100% minus something that you can explain over total. Okay, so you get two equations here, SSR over SST, or 1 minus SST over SST. Okay, typically R square is between 0 and 1. 0 means 0%. 1 is mean 100%. For example, an R square of 0.6 reveals that 60% of the data fit the regression model. Let's see, this figure will help you. If all of the real data are in your regression line, if you face the situation like it and you compute R square, you may get R square equal 1 or 100%. But if the regression line fits really well, but not all of the data are in regression line, okay, you have some minor error, error. Maybe R square around 0.8, which means 80%. Then, if you face something like that, the data is not in your regression line, but still close to your regression line. It somewhat have larger error than previous figure. So you get r square maybe equal 0.4. Okay. Oh, and then if your data is maybe not so good and the regression line cannot explain the relationship between two variables, you may get r squared equals 0. So bad, no good, inconsistent. Okay, so typically r squared between 0 and 1, 0% explain or 100% explain. Okay, let's see the printout. Okay. Before see the printout, this is what the data that we already calculate together, and you can calculate r squared by SSR over SST of 1 minus SSE, which means sigma L S squared, okay, over SST. Okay, so you can get 5.87 over, oh, no, sorry, over 118 or 112.13 over 118. So both way you get 0.95, which means 90% of the data fit the regression model. Okay, you can see the figure. They fit the data really well, just some minor errors. So you get R squared equal 0.95, which means your model is very good, very fit the data, very fit the real data. Let's see the printout. Okay, this is the printout that you have to know how to read it. Again, dependent variable y. Method least square, so they use OLS. Included observation, so n equal 5. Coefficient, okay, standard error and t-stat. So coefficient, standard error, and t-stat equal 1 over 2. Okay, and the probability I told you already, they are forecast here, greater than 0.1, less than, less than, and less than. Okay, you have to know how to read it properly. And here is r squared. Okay, r squared. What do you need to know is mean dependent variable. So this is y bar. SD dependent variable. This is standard error. Is mean square root sigma y minus y bar square n minus 1 or root SST n minus 1. And sum square lecit is sigma error hat square or SSE. Okay, so before we take some rest, can you help me how to read this equation? Okay, first r square equal 0.95. What does it mean? Yes, of course, correct. This means your model is very good because it fits well 95%. Your accuracy is very good. If you use this model for forecasting, this would be a good model. And then let's help me read this probability. So 0.0048 is mean 0.01, which means okay. Uh-huh. Mm. Which percent? 99%. Yes. Perfect. Good. Very good. Okay, follow me. So R square equals 0.5, which means 95% of the data fit the regression model. Or this is the word that the textbook use, or the way I always use this, the model can explain 95% of the data, which is really well accurate. Then this is beta 1, this is beta 2. So to interpret beta 2 at equal 1.93, which probability equals 0.0048, which is in this case, indicate that if x, okay, you use x here, if x increase by 1 unit, dependent variable y will increase 1.93 and significantly, and okay, you can use 1% significant level or 9% confident. Either is okay. Depends on your understanding. So well done, well done. So this is the basics when you deal with the real data and get the similar printout like this. Hopefully you can read first, you can read R square, whether the model is good or bad. Okay, if R square is low, which means it's not so good for forecasting or something. And then the more important is the significant. This significant, if you know how to read this well, okay, the life will be easier when you deal with the real data. You can say, oh, whether block is less than 0.1 or not. If not, oh, your model maybe cannot answer those questions. Okay, so you expect this probability to be low, very low, and this means it's affect significantly. Okay, let's take some rest. You may need it. So, do you want to go to drink coffee or something? So, okay. So maybe less for 20 minutes. Okay. So let's get back here. 3 p.m.
Goodness of it。对，那个是 SS 是吧？他说的应该不是那个，他说 error 是 ERROR 那个什么？不是，我说的我知道你说的是什么，但我不知道他说的是什么。他那个是西格玛和的意思啊，和西格玛。啥意思？和嘛，和你大哥，你看这个多少钱？哪个？所以就是这个和这个东西的和。你看这个值嘛？你看这个值嘛？你算过没有？第2节课的时候来着，第一次坐在这里的时候跟他一起算的。对，好吗？然后 arrow 是这个。这个是 arrow， 对 ，arrowhead 的方。arrowhead 这个 arrow 是啥 ？arrow 就是错，有误差的差。这个 stand arrow。这个。arrow， 然后这个是西格玛和，笑死我了。西格玛在哪？西格玛就是那个很像 E 但不是 P 的那个。还有这个。弟弟呀，你只有学到哪一？我上次问我那个问题，我直接笑出来了。你哪一天？不是，这太难了。对，是，我快慢慢来，笑死我了。我俩就后来做笔记都做到傻了，就是我靠，这个表情在说什么？我们都没有顾不上了，已经。我也是这样，我太恐怖了。他跟我说的时候，我也在看他，那我还是想说，是不是要买本书？而且你发现没有，从一开始断开了，后面整个就好像那个节奏都不对。要是节奏对了，我就那个靠，最近在耍手机，我学不下去了，我学不下去了。你按这个可以的，但是学不行了。再学我要死了，再学也死了。我记得前面他好像讲这个的，我就一下子找不到我做过的那个。上那个 homework 上面，在那个 homework 上面他写的，烦人，突然心情就不好了。很多人都不开心。必须出去下这个。他现在都不觉得冷了。不冷，他就觉得他是到处不冷。 心里凉凉的。我们之前那有人，心里凉凉的，觉得凉凉的。哦，你说我这个好像，我估计我们讲完的应该下课了。
他后面还给了那么多东西，那些对那个软件。
先不要说话，那我们就先愉快一下，不然内心要崩溃掉。I call. You call already? I think you call already, no? You call. No. 哦，空档机。哦，然后头。哦，那我现在叫车好吗？你家里乱不乱？家里乱不乱？OK，那我现在叫啊，拜拜。
偷我怎么
I want to know, they use which, what app to do like your homework.
I think it's MATLAB. Yeah, MATLAB. Very complicated เหมือนกัน yeah, it's all there. Oh, difficult. Why do you do that? Which professor made them do that? This is the leader. Okay, I bought from the charging province. I went from charging province here is close to bank. So let's try. If you let's try the snack because I saw you on very yes yes. Charging town, it's like 1 hour and a half from here. Like
Like snow, snow, snow.
or east is to Bangkok. So if you go to Pattaya, okay, yes, it's go to Pattaya. Before Pattaya is already. Okay, before Chonburi.
Oh,
Before Chonburi. Okay, this next one they have to favor. So you have to. It's like a panel list. Panel list. So what are custom? This is IT. I think IT is my favorite. So what do you want? Okay.
我们3个人开一起，
Let's try. Let's try. This is like a most famous snack, most famous teacher in this province. And then custard. ขนมปังสังขยาตัวแทน then custard.
他们，
You may very with the lesson. I know it's difficult, but it's good to learn it. Okay, so let's back to our lesson. Again, you can eat along with the lesson. That's okay for me. Okay, so this is like all the basics that you need to know when you do with econometrics. Okay, so you have to know how to read R square and you have to know how to read probability. So the reason behind I already told you uh, that okay, you may have to do the 4 steps, and then when you face the real data, you do not have to do that, but to read the probability instead. So typically they have 4 ways to interpret the result using the probability. And then we start some issue about the model. First, how about the effects of scaling data? Imagine, for example, you would like to find the relationship between expenditure and income. You would like to know whether the income, the higher income, the higher expenditure or not. And then you go to collect the data. Oh, this one they used to 20,000, while their income is 30,000. The second person, maybe they use 30,000 per month, but his income is 50,000 per month. And then you already do the equation. Yes, you already do the equation and you get the beta, for example, 0.8, and you submit it to your professor. And then professor would like you to do something. Professor said that, oh, income, they have too much zero. Can we divide it by 1,000 and use this one instead. You may tell professor why you give a lot of homework to me. Okay, so this is like a effects of scaling data. So what will happen if you divide the number in your model? Okay, first changing the scale of x. Okay, so y equal beta 1 plus beta 2 x plus error. And then one day they divide x by 1000. What will happen? Okay, so to make 1000 valid, okay, you have to multiply 1000 back to make it equal number than before. So after you divide by 1000, you have to multiply back 1000. Why? Because 1000 over 1000 is 1. Okay, so you have to divide, multiply 1000 back to the model, and then this is your new f we call x star. Then y equal beta 1 plus beta 2, but beta 2 now you have to multiply by 1000. So 1000 times beta 2 new x. So what happens if you change the scale of x? So y remain the same, right? Beta 1 same, beta 2 increase by 1000 times, and error same. And then what happens if we change the scale of y? Of course, we do the same thing. Y equal beta 1 plus beta 2 x plus error. And then one day, professor told you, hey, please divide y by 1000 and make it negation again. So after you divide 1000 on the left, you have to divide 1000 on the right as well. And then you will get, okay, this will become the new y here, so it's y star. So equal y star equal beta 1 over 1000 plus beta 2 over 1000 x plus error over 1000. So you can answer that intercept is less than before by 1000 times. Okay, so beta 2 is over 1000 and the error is over 1000. This means the scale of the data does not affect the result. Just change the scale of data. Okay, the result will be the same as before scaling. Okay, this is the first issue if you face this scale data. The second issue is to choose a functional form. Okay, there are several functional forms to choose, like linear, quadratic, which means square, cubic, which means you have to power by 3, log linear model, log model, and linear log model. Okay, you start to check again. Okay, let's see the the figure. Okay. For example, if you fetch the data, okay, when you obtain the data, I highly recommend you to plot the data first and then you plot the data. Oh, professor is somewhat parabola here, but since I learned with you and you taught me to do a linear model, then I do the linear model. You can say that this one must be incorrect, right? So after you plot the data, you may see that, oh, this model, if we use some model that we can project the data to be this one be better. This one would be better. Oh, sorry for my handwriting. Better. Okay, so let's see next figure. This is like the sheet. My uh, my tongue is not working. So this will be the sheet sheet sheet. Okay, like if you plot the data and you don't know which equation you have to use, let's come back to this slide and see which equation is fit well with your data. For example, if you face something you curve like a parabola, you have to use quadratic equation square. Okay. The advantage if you use a parabola equation, it means if beta is greater than 0, you can find the minimum value here. And if beta is less than 0, you can find the maximum point here. Okay, you may learn in the microeconomic theory class that sometimes they would like you to find max profit, minimize consumption, right? Minimize cost, max utility, something like that. So to deal with those type of questions, you may put square on your equation and you can find any max or min. Okay, later I will teach you. And then if you face some data similar to this curve, you may use cubic equation by power by 3. Okay, so typically they use it on the production function in microeconomic theory. Okay, the rest is log model. Okay, log model is depends on your beta too, so you do not need to remember, just see your data and try to choose the most fit model to your data. Okay, so then after you can choose the most fit model, you have to know how to make the interpretation of each model. Okay, so this one is good, but I found that it's a bit tedious. So let's summarize it together and you will understand. Okay, so come to this slide, come to this page 16. Okay, we start from linear. So lin is from linear. which means you put y or x alone. But if I say log, okay, it's a logarithm. I don't know how to write it, logarithm. Okay, so logarithm, which means you put log on it. Okay, so typically log on is they use like a natural log. Okay, then we usually use four types of model. First, the most basic one you learned it already is called linear model, which means both sides are linear. Then, when you have to write interpretation of beta 2, so beta 2 means if x increase by 1 unit, y will increase beta 2 unit. Okay, this is the most basic one. You can interpret it in your usual way. But if we face log model, which means you have log on the left, log y equal beta 1 plus beta 2 log x. I have the tips, like a tips here. Log, you have to interpret as percent. Linear is you have to interpret as unit. Then log x, you have to interpret as unit. So x increased by 1% because they have log on it. Then if x increased by 1%, y will increase beta 2 and y have log. So beta 2%. And this is very important for economic theory because they call this type of beta as elasticity. Elasticity. Yes, you may face a lot in microeconomic theory. Yeah. Then log linear. Okay, log linear is mean on the left is log y, but on the right is x because it's linear. So linear you have to interpret as unit. So if x increase by 1 unit, okay, so let's see all of the slope interpretation you have to interpret compare with 1. Okay, if exchange 1 unit, if exchange 1%, y will change beta 2 unit, y will change beta 2%. So if x increase by 1 unit, y will increase because they have log, right? So beta 2%. But be careful, you have to multiply it by 100. And final ln log, so y equal beta 1 plus beta 2, but log x. So x have log, so you have to interpret as percent. So if x increase 1%, y increase beta 2 unit. No, because they are linear. But to interpret this one, you have to divide it by 100. You change the color. Okay. So this one is one of the most important thing when you do the model, okay, to interpret it correctly. Okay, when they are a homework that please make the interpretation or please explain your result, you may come back to this slide and see which model are you facing. Like if you face log, you have to interpret as percent. But it's log linear, you have to unit and percent. So let's quickly practice. If I say that log income equal beta 1 plus, maybe I will put the random number here, 0.04 experience. What does this mean and how can we interpret this better? Then you have to answer that since experience, if experience increase 1 year, 1 unit, right? 1 unit or 1 year, then income will increase. Is 0.04, you have to 0.04 multiplied by 100. So you can answer that 4%. It means yearly income will increase 4% per year by your experience. Okay, if you work there for 1 year, income automatically increase by 4%. Okay, so this is how we interpret log linear. How about, okay, one more example. How about if I use income equal beta 1 plus for maybe experience. Not a good example, but yes, it's not a good model because if you use linear, it means this is 4,000. Sorry, it's too good to be true. 40,000 too good to be true. Okay, if you face something like this, so linear, right? It means if experience no log, so increase 1 year, income increase 4,000. Yes, sorry, 40,000. It's okay, but I think it's unrealistic. Increase too much. So 4,000 is possible, 4,000 per year. So increase 4,000 units. So it depends on the unit from the question. Like if they say baht Thai, you have to say baht. Okay, increase 1,000 baht, for example. Okay, you see the difference here. If it's linear, you have to interpret as percent instead. But if it block linear, you have to interpret as percentage instead. Okay. Okay. So then we have several types of model to be choose and then to be chosen. And you may ask me that which model is preferred. Since we can do both, like we can do linear, okay, interpret as 40,000 baht, we can interpret as percent. Those, those seem both really good. So which one should I do? So they have like a step to choose a functional form. Okay. First, like I said, you have to choose a shape that is consistent with economic theory. Okay, so theory comes first. For example, the most famous microeconomic theory, they always assume production function, right? To be Cobb-Douglas function. You may face this somewhere, huh? Cobb-Douglas function, right? Have you ever heard about this? Cobb-Douglas in microeconomics? Yeah. So Cobb-Douglas function, it means you have to interpret as percent. So production function with the economic theory, you have to use log model. Okay, so you may start from theory first, but if theory professor theory don't say anything about the equation, okay, then please choose a shape that is fit to the data. Okay, if we face some parabola, then you have to use parabola equation. Okay. The step, choose a shape that other assumptions are satisfied. Okay, so first we choose by economic theory. Second, we choose using the data. Third step, like we choose using econometrics theory. Okay, so you must recognize that we never know the true functional relationship between economics variables. Also, the functional form that we select, no matter how elegant, is only an approximation. Okay, so our job is to choose a functional form that is satisfactorily meets the three objectives stated above. Okay, so first step, that's okay, based on theory. Second step is based on data. How about third step? What does it mean? Error assumptions are satisfied. What does it mean? Okay, so let's back to the basic one. Okay, maybe next slide. Next slide, can you change the number for me? I made a mistake. This must be number 3. This must be number 4. And this should be number 6. Okay, so do you still remember the thing called Gauss-Markov theorem? Gauss-Markov theorem, which they have 1 to 6 rule. Okay, and they said if 1 to 6 rule are true, OLS must be the best. Okay, something like the Gauss-Markov theorem. And then I pick some of the rule here. First rule, variance of error must be constant, or is called homoscedastic. What does it mean? Okay, if not, we call heteroscedasticity problem. What does it mean? Okay, four, error has no relation with each other. If not, we got a problem. And six, error must be normal distribution. We will learn how to check in detail in later chapters. I think you have to learn with the second professor in the after midterm. Okay, so in this chapter, we start from plotting error to see it approximately. Okay, when you have the data, I will quickly show you in detail. Okay, I get the new backboard. Can I have the older version? Okay, let's do it. Okay, so for example, if you have data, okay, if you have data and you plot the model, this is your model, and the dot is the real data. So every point here is error, right? Error, 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 error. Then I try to plot the error as well. So here we plot the error, we plot the error, we plot the error, we plot the error and error. And then we see the pattern. Okay, we use your eye. This is eye. We use your eye to see whether any pattern of error. Okay, so this is the source of error plot. And then let's see the beautiful figure, not my figure. Not my figure is just example. Okay, so this is the residual plot, which means residual means error hat. Okay, so you put error hat to plot, and the good model, when you plot an error, is the pattern must be random. So this one is the good one. Okay, your error is random. It means your error has no pattern. It's just randomly occur. You don't know how to predict any error. But on the right hand, error hand here, they have something like this. The variance, when income is low, variance is low. But if the income higher, the variance is higher. This is called variance is not constant. In technical terms, they say you face heteroscedasticity, aka they use hetero. Okay, just in short, hetero problem. How about the second one? The second one, there's something pattern. Okay, residual go up with X and then go down. They have a pattern. So they have relationship between error, which means you have auto correlation, aka they use auto. Okay, you will learn it heavily because this one make this subject difficult. It means whether your model is accurate or not, can we trust in the number that we found? So you have to check whether, okay, the assumption is correct, no problem, error is good, error is no pattern at all. Okay, so this is hetero, this is auto, and moreover, most modeler serious about whether your error has normal distribution or not. So they use the Jack Vela test by setting H now to be normal, okay, versus H1 not normal. Then the second step, they choose this test, okay, we do not need to know it. Third, they choose a chi-square test and then they make a conclusion. Well, do not serious about the test, but you have to know how to read if you've been out. Okay, so the keyword is series residual. So residual is error and. So if you face similar figure here, please jump to here. Chart, Bela, and probability. Okay, so you can read the probability here. For example, at 95% confident, if block here is greater than 0.05, less than 0.05, it's go to H now, which means normal. Your model error is normal distribution, so no problem. So you must prefer to get this one. But if it's less than 0.05, it means not normal, which means your model has problem because your error is not normal. But you can kill it by collect more the data. Okay, the normal distribution, if your error is not normal, you have to collect more data. Okay, hopefully you understand how to read the EView output. I will teach you how to do it today. Let's see example first and then try it together. So example, this is the yield. Okay, the like a agriculture yield depends on time. So as the time goes by, the higher yield, as we can see in the figure, and we can see somehow curve, right? Not linear. But if you use wrong functional form, let's see, we use wrong functional form by make it linear. Okay, it means after you face this figure, you try to use linear. Is it correct? Maybe not, right? Because if you see the data, it must be something like this, not this one. Okay, so they try to make this equation. Then they get equation, they get r square L. What does it mean? Please tell me. R square equal 0.649. It means 64.9% of the data with the model. Yes, professor, it's 40, 64% is good enough. Why? Why you don't allow me to use this model? So I go and plot an error. Okay, so this is the data and this is the model, and we plot the error, and we can see some pattern. They down together and they went up together, which means your model face auto correlation. Model is invalid. Then the second researcher, they try to make equation by make power by 3. Okay, make the power by 3 here. Then it's curved well along with the data, and you can find any pattern of error. Okay, is no pattern. So this model is better. Even R square is higher. More example. Okay, more example. Example 2, log model is frequently used for demand equations. Consider, for example, the demand for chicken, which is uh, adapt from the data provided by someone. Okay, scatter plot is here is the quantity of chicken Q and P, and this is like a demand function. Okay, so the higher price, the lesser quantity. Okay, so this is like a demand curve. But they would like you to use a log functional form. So they did log functional form here and then get R squared. Answer me loudly. What does it mean? Now 88.17% of data fit the regression model, which is quite good, right? Because the maximum we have is 1, which means 100% of the data, or 0, which means none of the data fit the model. So 88.17%, quite good. Okay, and how can we interpret this beta log model? So you have to interpret both sides as percentage, which means if price increase 1%, okay, 1% increase in real price is a negative, right? Because it have a minus, so it reduce consumption by 1.121%. We will estimate this equation together in euro and then try to test whether the error of the model is normal distribution or not. So let's open the data I provide you in Google Classroom. So the data name is boiler. It's loading, long time, but just keep loading. Okay. Okay, so we have several data, so please download new boiler work file, because the other tools will be your homework. Okay. Can you install eView in your laptop or not? Or alternatively, you have to come to university and then use computer room to do homework. But if you have laptop, let's try to install eView and do your homework. Okay. But okay, this time you may do it together in the class by using the computer room's laptop. So open new boiler. Okay, you have to double click on new boiler work file and you will face eView window. Okay, everyone open you. Same file as me. You correct. Boiler. You new boiler. No, new boiler. Yes. Okay. And then the equation that we would like to do this time is as the example we would like to do log Q equal beta 1 plus beta 2 log p. What should we do? What should we do? Then from last week, you have to click on object, new object, equation, and name the equation to any name you like. Object, new object, equation. Okay, then make sure that your method is least square here. Then try. Okay, if you would like to make log model, you can type log in eview. Okay, so log q c log p. Okay, then click OK and see what happens. Do you get the result? Okay. So this is when you deal with the research. So you have to collect all the data and just come here and click the model. That's easy, right? Do not do first step S now, S1, F stat, open table. No, you don't need to do that. You need to read probability. Okay, so first your R square is 0.91, which means 91.36% of their fit the regression model. Good. Yes. So it typically means 91.36% of data fit the regression model, or the model can explain 91.36% of data, which means your model is quite good, very good one. Then you see probability, which case is less than, which means 1% significant level. So how can we interpret this coefficient? Is log 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 mean percent, both percent. Okay, you can watch again in the YouTube. Nah? Okay, so to interpret this one, so beta 2, right? So beta 2 had equal minus 0.12 with pop is less than or equal 0.01, indicate that if price increase 1%, good, quantity of chicken will decrease, yes, decrease by minus 1.12%.
So we don't because multiple one.
Yes, because it's log model, not log linear. Let's come here. Yeah. Good point, good point. Log model. Yes, just better. But if I use log linear, you have to multiply it by 100. Good point, good point, good point. Good. Yes, it's elasticity. It's elasticity. Okay. So you can, oh, where is the pen? By model, it's gone. Okay, that's okay. So typically, this is so called in economic theory as elasticity of demand or price elasticity of demand. Yes, but okay, you may learn it in microeconomic theory, right? Price elasticity. Okay, just test your knowledge. That it will not be the exam. Okay, this case 1.12 is mean it elastic or inelastic. Inelastic or elastic. No, not will not in the exam. Just for for fun. Okay, so this case is elastic because it's greater than one. And yes, this minus this means the absolute value is greater than one. Okay, it means if you change the price a bit, the consumption level will change more than the price. If you are the owner of this shop, okay, imagine that you are the owner of this shop. It means if you increase the price, it will decrease your revenue. You do not need to increase the price because your revenue will decrease because some of your consumer will go to buy other goods instead. Okay, those are microeconomics, not my subject. My subject will ask you better how to read this probability. Okay, then let's click on Lesis here. Lesis. This is the pattern of error. Okay, so the orange line is the real data, and the green line is the data we forecast or predict using the model. Then the difference is error. So seeing this figure alone without any calculation, can we see any pattern of error? Do they have pattern? But I see the pattern now. Hmm. 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 Yes. Right. So maybe this model costs auto. Okay. But again, you may have to learn it later. In the like after midterm, you have to learn it heavily. So this one just plot the data and see. Mhm. Then, if you come back to the main window, which means your work file, here, click back to your work file, and let's find lazy, 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 which means residual or error hat. Okay, so double click on it. Okay, this window pop up already. You get this one. That's it. Okay, so come back to the main window. Your work file, new buyer. Find the name lazy, which means residue or error hat. Double click on it. Okay, I will show you how to test normal distribution. Okay, so the modeler expect error to be normal distribution. So S now will be normal versus H1 is not normal. Okay, so after you get lazy, then click on view polylogram. Not so sorry. I forget to do it. Okay, view descriptive statistic and histogram and stat. This one. I confused between histogram and polylogram. Good. Yes. Click on it. Good. Yes, good. Okay. Before we finish the class today, please answer me. Please answer me. Okay, I give you information already. When we test normal distribution, H0, H now normal. H1 not normal. Probability 0.4. Answer me loudly. This model has normal distribution of error or not? If you answer incorrectly, we have to continue the class 3 more hours. Normal distribution. Why?
More than 0.05.
Yes, because the prompt said that more than 0.05. By using Jack-Bella test, since prompt is greater than 0.05, error is normal distribution. Pass. Very good. And that's all my lesson for today. Hopefully you understand more about econometric, and please review, okay, what we have learned, because the next chapter is level will become higher, which means the model will be more complicated and they have a lot of issues about the model. So hopefully you can read R square, you can read probability, okay, and see S now in this one. So let's see homework before we finish the class today. Okay, so homework, very long, very long homework. This is the vote equation for election. Okay, so they have the data of vote, percentage share, and the growth rate, which means they expect that if the politician did well, which means the country has higher GDP growth, the popular must be increased as well. Okay, so they estimate the equation for you already. Okay, so the higher growth, the higher vote. Okay, let's read it together. After we get print out, what will you read first? Okay, good. Okay, good. Yeah, R square. Yeah. Okay, then R square equal. It,
Is the regression model?
yeah, good. So let's first read R square is 34%. Not quite high, but not quite bad. Just 34% of data. But that's okay. Then we read probability. Yes, it's less than. No, this case they have 4 cases. This case is. Yes, yes. So again. Okay, before we finish the class, I would like to make sure that you understand how to read the probability, which is the most important in this class. Other is just technique. So when you see, okay, R square, no problem for you because all of you can read R square right now. But for probability, okay, for probability, first you have to know that this is coefficient, this is standard error, and this t stat is 1/2. Yes. So if, for example, if my exam hide this number, can you calculate it back? No problem, right? Then when you face probability, you may, let's see the case. Okay, first, if it's greater than 0.1, this means not significant. This means you can say that it's not affect X, not affect Y, or X affect Y is not true. Either is okay. It's not true. Yeah. But if we face that is less than or equal 0.1, we call it significant. But we have 3 significant level here. First, we call 0.01, 0.05, and 0.1, which means it's significant at 1% significant level, 5% at significant level, and 10%. Or if we write down in terms of confidence, it means 99% confident, right? 95% confident and 90% confidence. Okay. can answer me this printout when I would like to interpret the effect of growth on board. The probability is 0.0003. Which case? 1, 2, or 3? Yuan is one. Mm. Significant level. Okay, you're good. How about you? Can you understand? Yes, when you have to write the answer, you have to write it for like growth equals 0.65 and the plot is less than 0.01. Indicate that if the growth increases by 1, the vote will increase by 0.65, significant at 1% significant level or 99% confident. This is how to answer. Okay, so let's try to do other equation as other question as well. So let's try first, and I will give you a solution next class before we start a new chapter. Okay, so this is 3.1. This is 3.2, and typically this is computer exercise, but this is like a homework solution. Okay, I have done it for you already, but it's highly recommend to use data file. Okay, I provide you data file is wow with. Okay, wow with, and I have 3 equations in my mind. Okay, then please do 3 equations by yourself. But if you don't do, you please try to read the equation instead. Okay, so if you would like to use program, please try to use program. But if you don't want, please try to read the model. For the first question, I ask you which equation do you think is preferable and why? Okay, let me know your opinion. Which characteristic or which number that you use to pick between 3 models? Why? And then interpret your preferred results. Which one do you choose between 3 models? And help me to interpret the result. What does it mean? So you may use this one. To help you to interpret the model correctly, right? Okay, if you prefer log linear, then interpret as log linear, something like that. Okay, so that's all for my class. Do you would like to study further? Okay, so you may ask anything you want, okay, but I will finish the video recorded. So thank you for today.